Hello, friends, colleagues, students, programming and JavaScript learners. This is the part 2 of looping control structure introduction. I'm showing the flowcharts, pseudocodes, and JavaScript code. I'm Dr. Satish Singhal, PhD, Professor of Computer Information Technology at Rose State College in Midwest City, Oklahoma, near Oklahoma City. So in last video, in part 1, we showed details of count controlled loop. This time we are going to show you one more loop which fits into category of something called event control loop. So let's look at that. This hierarchical diagram here shows you classification of the loops in general in most languages. There are two types of loop: count control loop, where we know in advance how many cycles or how many iteration the loop is going to do, and loop counter starts at a value and gradually approaches the termination value. Okay, this loop is very useful when we know in advance how many times we want the task inside the loop to be done. It's great for iterating through collections like arrays, linked lists, and things like that. Any collection iteration is excellent when we use the count control loop because we know how many elements are there in the collection in advance, and we know how many elements we want to iterate through. It's really a great loop for that. But there are other loops, other software situations where other loops are needed. So second classification is called event control loop. We'll explain the meaning of event in a second. But basically, when the loop is to be exited, an event is caused by some data entry inside the loop. And that allows the termination of the loop. And of course, loop conditions initialized in case of pretest loop outside the loop, and then event is created, data value that causes the event is created to terminate the loop. And this has three subparts, three types of events. Something called a Sentinel Control means a Sentinel value causes an event to terminate the loop. Flag control loop means a flag value is changed. Flags are Boolean flags, and we'll discuss that also. And third one is the end of file control loop. This is a powerful loop, except in JavaScript we don't use it very much. JavaScript is not allowed to read files on the client computer, although on server it can. But we will not discuss that in this video or video in this series. But this has been discussed extensively by me in the Java file processing and C++ file processing. Okay. So in this series, we'll limit ourselves to Sentinel and flag control loop. Okay. All right, let's do Sentinel control first. Or in fact, we want to talk about event control versus count control loop one more time. We saw in the example in previous video where we printed happy Halloween 10 times, and the loop counter started with 0, but as program progressed, it gradually progressed towards termination value of 10. We demonstrate that one more time in JavaScript code. Actually, I will not demonstrate that. You can just watch the previous video. Otherwise, this will add cycle time to this video. Okay. So please watch video 1 for the demo of that. Okay. So what we saw in that case was that there was a gradual progression towards termination value, and this gradual progression towards termination value in count control loop is the hallmark of count control loop. which is very useful for iterating through arrays and other collections. But the other type of loop, which we are calling event control, is different in nature. In event control loop, the termination condition is reached not gradually, rather it is reached suddenly. Okay? And we want to say more about that. So the condition that terminates the loop is called a loop termination condition. And in pretest loop, the loop condition is tested at the entry point. If condition is true, loop is entered. If false, loop is not entered. And loop will continue to execute until in an iteration the loop condition update is such that the loop condition will evaluate to false. Okay? The value of the loop condition that evaluates to false is called the termination condition. Okay? And there's a definite relationship between loop condition, entry condition, and the termination condition. Rather, pretest condition and termination condition. And we want to show that relationship mathematically, sort of mathematically, because there is a fixed relationship between pretest loop, pretest condition, and the termination condition, and that does help us design the loops. And the relationship is such: the pretest or test condition, loop test condition, is negation of, and you would recall the negation is an operator in programming languages. So pretest condition or test condition is negation of termination condition. Negation is represented by the not operator. So using the not operator, which is used in Visual Basic and in pseudocode or flowchart, we can say that pretest or test condition is negation, not termination condition. And in JavaScript and C++ and C# and C and Java, we use the bang or the exclamation for not or negation. So here we can say the pretest condition is the negation of termination condition. Okay. And we want to point out one more thing, that application of not or negation operator converts true to false and false to true. That was done in the truth table when we discussed the truth table. Okay. So pause this video just a little bit right now and make sure you understand that. Later on we'll show you something called De Morgan's rule, where this is applied in more detail. Okay. So back to event control loop. In event control loops, the loop termination condition process or loop terminating process suddenly sets the loop condition to a value equal to the termination condition. And once the termination condition arrives, the loop condition is false. That is why such loops are called event control loops. Okay. Event that transpires is the one that brings about termination condition as the value of loop condition is being tested. We'll show example of that shortly. But for now, let us review various event control loops in general and in JavaScript. And we are back to that slide again. Event control loops are three types: Sentinel control, flag control, and a file control. Today we'll talk about this. So let's get back to Sentinel control loop. To understand Sentinel control loop, we must first understand what is a Sentinel value. We want to make sure that nobody is confused about that. Okay, so let's look at the data that computers process data, loops process data, and nature of some data are such that while they would have possible values, they would also have impossible values. There are data that have two types of values, possible and impossible. And impossible value is made impossible because having that value for the data will lead to violation of laws of nature or the laws of country or laws of some institution, or it would be against accepted norms. That's what makes value of certain data impossible. That impossible value of data is called a sentinel value. Okay. So summarizing again, sentinel value is an impossible value in magnitude, but it has the same data type as the possible data values has. You cannot change the data type when selecting a sentinel value. Okay, and we'll talk about that very shortly. Let us take an example of student score in a test at Rose State College or other community college. And pause the video right now and think what it could be. What can be impossible value for a test score in a test? Okay. Thought about it? Have a value in mind? Fine. Let's see. So what will be an impossible value for a test score for a student in a community college? If you thought impossible value is 0, well, that's wrong because a student can get 0 in a test. And if you thought that some large value such as 1000 is a sentinel value, well, that will be wrong also because professor can give 1000 points test in multiple parts. And when I was giving this lecture, one student said, well, infinity could be an impossible value. True, no question about that. But how do you enter infinity into the computer to process it? So we cannot tell computer a value that it cannot process. Okay? There's no way to enter infinity from the keyboard or from a file. So it's as simple as that. Has to be a real value, basically, that you can type on the keyboard or somewhere. Okay, so what is the sentinel value for a student test score in a community college, for example? Answer is the next slide. A logical sentinel value for test score in most community colleges will be a negative value for the test score because most community colleges don't give minus points in a test. The magnitude of negative value is not important, just any negative value would do. But at the same time, notice that this rule about test score cannot be negative is not universal. Java certification exam awards negative points for wrong answers. And in that case, negative test score is no longer a sentinel value. Okay? So make sure you also know where the data process is being done. Maybe test score negative is not a sentinel value there. Okay? Okay? Think about sentinel values for following data. Pause the video and write those down, answers to those. What is the sentinel value for salary of an employee in a company? What is the sentinel value for number of days in February? What is the sentinel value for number of months in a year? Pause the video right now and write down answers to these. Keep them for now. Did you think about answers to sentinel value asked earlier? Okay, keep your answers. As much as you are curious to know the answers, we'll show our answers at the end of the video. All right, keep watching. Okay, so I want to design a sentinel loop to get average of blood pressure readings. Imagine a doctor wishes to get an average of blood pressure of all of his or her patients in their practice. Well, you can say, why would they need to do that? Well, here's the reason. If average blood pressure of all patients is higher than expected, then doctor would know that they are practicing with the population that has tendency for hypertension. And based on that, doctor may decide to give hypertension care seminars, lectures to benefit their patient. So it will be a good addition to their practice. Well, then what is the sentinel value for patient blood pressure? We can think of many values, but a convenient sentinel value is a negative value for the blood pressure. Okay. And the non-sentinel value will be real value of the blood pressure taken in doctor's office. And then sentinel value will be negative value. Okay. So what will be the loop termination condition? In the blood pressure averaging program, the termination condition will be when user enters a negative value for blood pressure. So pretest condition, loop test condition or pretest condition will be blood pressure greater than 0, where BP is blood pressure. Loop termination condition will be BP is less than 0. Okay, meaning that a negative value, which is the sentinel value for BP, is entered. Here's the flow chart, and I have slight error in the flow chart. Correct that error. We're not going to use the equal sign. So it's BP greater than 0. That's the condition here. So we'll start. We'll need two variables in that. To average blood pressure, we'll sum up all the blood pressure readings and count how many there are. So we define those two variables. Actually, we should define BP also here. So there are a few errors in this flow chart. So BP should go here as well. So we read the first blood pressure reading. This could be from a keyboard or from a file. And this will be the initialization of the loop condition. Okay? Because BP is being tested here, so it must be initialized before the loop. Then we test whether BP greater than 0 is true or false. If it is true, then sum that was set to 0 here, we add the BP read to that, and since we got one value, we increase our counter by 1 also. And the update of the loop condition will be, we read the next value of blood pressure. And once again, if this condition BP greater than 0 is true, then we'll repeat this task again. We'll read the third blood pressure value, and we go back, and if the blood pressure greater than 0 is still true, then we'll do sum and count again. Once the negative value for blood pressure is entered, BP greater than 0 will be false. We find the average, and we print the average. Let's review that. Okay, 4 things: initialization of loop, pretest, loop task, and update. All 4 are present that they should be in any loop design. Here's the pseudocode. Let's discuss this through pseudocode one more time. So we set sum equal to 0, BP equal to 0, counter equal to 0. We read the first blood pressure reading. That's the initialization step. While BP is greater than 0, I say sum equal to sum plus BP, counter equal to counter plus 1, and read the next value of blood pressure. This is the update of the loop condition. And this loop keeps going until in the update reading, user enters a negative. Negative greater than 0 will be false. And then I'll exit the loop. And then I get the average is sum divided by counter, and I print the average. Now some students are confused, and I don't really see why there's a need for that confusion. It could be that they kind of think that it's kind of unnatural to do a reading here and do another reading inside. Well, you need to understand that this reading and that, they have totally different purpose. Here we are initializing the loop condition, and if they entered a negative value right here, then loop will not be entered at all. And that could be true for some patient which came to office, and for some mix-up, their blood pressure was not taken. Okay? So that can happen. All right? So this is the initialization of the loop condition, and this is the update. Both are needed, initialization and update. So there's not really an issue why we have two places to read. First place is done just once to initialize the blood pressure loop condition. And it's a part of the sum. It'll be part of the sum, but it's needed outside the loop so that we can use this loop condition here. Later we'll show you that you can avoid reading here and here using a flag control loop, although that has its own problems. So in Sentinel Control loop, which is set up using a while or a pretest loop, you have to read one value outside the loop for the initialization purpose, because you are initializing this condition here. And then you have to have another reading for the update. Okay? So this is not a surprising thing. This is a completely normal behavior in a Sentinel Control loop. One reading for initialization purpose outside the loop, subsequent reading for the update purpose inside the loop. Completely 100% normal behavior. Okay, now we have the JavaScript code, and rather than actually showing the JavaScript code in 3 slides, I am going to prepare this in a JavaScript file, and I'll pause the video recording just for a second to do that and come back when I'm done. Actually, sorry, let me click here. Okay, so here is our JavaScript program based on the pseudocode and flowchart we did earlier. So since we are going to sum up the blood pressure reading, we need a variable for summing them up, and we're going to count how many values were entered. So we have the count variable for that. We're going to get an average of the values, so we have average variable for that, and we need a holding place for the individual value of blood pressure, so we have variable BP for that. In JavaScript we have line break always because we need that. So first thing we do is priming the loop test variable or the initialization. So we do that through this statement here. We prompt the user enter the blood pressure reading, negative value to exit, and to convert it to numeric type, because prompt method returns a string, we multiply by 1. User could enter a negative here, that means there will be no blood pressure values, and count will remain 0. So that fact will be used very shortly. But if they enter a positive value, then, and I do believe we made it greater than 0, so we'll keep that. So and let's see, I guess Command S will save it. So I saved it. So if value entered is greater than 0, then BP entered is greater than 0, then this will be true. So I add to the sum, which was actually initially 0, the value entered in the priming, loop priming or initialization here. And then since I got a value, I increase it by counter by 1, which was 0. And then the update is done by the same process which we did the pretest or the initialization. So we ask for the value again. So if there is a next value available and that's positive, then this loop condition will be true. And with this next value is added to the sum, we increase the counter by 1 more, and we ask for the third value and so on. So this loop will be exited when a sentinel value for blood pressure, which is a negative value, is entered. Negative greater than 0 is false, so we exit the loop. And if we at all enter the loop, our count will be greater than 0. So if count is not 0, and we do that by avoiding the horrible mathematical problem division by 0. So we get the average, sum divided by count, and we print the average and the number of blood pressure readings. Otherwise, we tell the person or the user that no blood pressure reading were entered. Okay, so let's run this program. And I had the Google Chrome here, which had the page opened. So reload. So it enters. So I'm going to enter just some values that average to about, well, blood pressure is what? About 120, less than 120, 110 is a good blood pressure. So I'll enter values around that. So I'll enter 100. And it says enter blood pressure reading, negative value to exit. So I enter 100. Then I enter 120. Then I enter 115. And I enter 125. And I think I had enough, so I enter -1. And the full blood pressure reading, their average is 115. Okay, so you can say that, how do we know this is correct? Well, I guess for that I have to print each individual value as well. So let's see if we can do that. Well, I guess I could do that. I can declare a string. So I'm really extending the program compared to what is in the PowerPoint. So I can just say var output string. And I can add each value to this output string. So first I can add to the output string like output string plus equals, here are the blood pressure values. And then each time I get a value, I can add that to this string to display it later. So just do the same thing. And I can just add BP. Plus some gap between the previous value and the next value. Okay. So that'll actually, and then I have to print it actually, obviously. So to print it, I can just add a document.writeLN statement here. Plus BR. So let me save that. So this time all my values will be saved as well. So let's reload it. So I'll just do the same. Let's say 100, 120, 15, 125, 95, and let's say 130. And that should be enough. -1. The Sentinel value now. Okay. So those were the values: 100, 120, 115, 125, 95, and 130. So 6 blood pressure value, this is the average here. And if you don't want these significant figures, well, we can make one more change. Let's see, I'm not going to demo it again because my video will become too large, but I'll show you how to do the rounding off. Well, for rounding off, all you have to do is that add average dot to fixed and give a value here that fix it to that many decimal place. So that'll take care of that. Okay. All right, so you can say, how the hell I know this is correct average? Well, ladies and gentlemen, it's extremely easy today to do mathematics. Go to Wolfram Alpha, copy and paste these values, and you're home free. So Wolfram Alpha, computational engine, okay, and I think if I place comma, that will be a little bit better. And it'll give us the average of those values. A little slow, but it'll work. So sum is that. Okay, try again. Should have given me the average too. Oh, come on. Used to. Let me put one more comma here. That's very surprising. Oh well, actually it gave it this time. 6 items. Here it is. It just sometimes it just plays games with you. 114.2 is the mean, and 114.166 will round off to 114.2. 114.2 and same. So our answer does match. Okay. There are more things you could do with this. You could actually print some number of readings and all those things in addition to the average. But really the central thing we were trying to learn here is that there's a central control loop for averaging the blood pressure. So we can enter here sentinel or non-sentinel value. If it's a non-sentinel value, then we enter the loop and we keep going until a sentinel value is entered in the update step, and we get the sum and count. We divide sum by count to get the average. And of course, if no values are entered, then we'll get this else message, and I can demo that rather easily. -1, and it says no blood pressure readings were entered. Okay, end of the program. Okay, so this is Sentinel Control loop, and I did promise that I'll get back to those answers that I asked you about, the questions I asked you earlier, and here they are. Sentinel value for salary of an employee, it'll be any negative value because we can't have somebody paid to us and have them work for us as well. Sentinel value for number of days in February. Well, a good value is 30 because leap year could have 29. Okay. Sentinel value for number of months in a year. Again, a good value is 13 because 12 is the maximum number of, well, 12 is the months, number of months in a year. Okay, so this was Sentinel control loop, Sentinel concept, how the initialization, testing, loop task, and updates are done in Sentinel control loop. I will very shortly see you in the third video, which is on the flag control loop. Thank you for watching. Bye.